All right, problem 4. This time we're given the pH and we are now going to calculate the H concentration, or the OH. So it's the opposite of what we did in the last problem. Last problem, figured out the OH or the H, we calculated the pH. This time we're given the pH and we have to do the opposite. How do we work the equation then? Let's find out. All right, so 4a, a solution whose pH is 5.2. So we want to know the hydrogen ion concentration in moles per liter. That just means square bracket. That's all that means. Okay, that's molarity. Okay? So we want to know the concentration of H. So we want to know this or that. Now, you can use this to solve for H, or you can use this to solve for H. I just say I would use the one that looks like it's easier or fits the problem. What do you mean? Well, in this problem, this is 4a, right? 4a. I was given the pH. This doesn't have pH in it, this does. I'm gonna have to use this equation. I was given that this time though. I was given 5.2 equals negative log point of H. So I'm gonna put that in as X because that is my concentration. It is what I'm trying to find. So how do I do this? How do I do this in my calculator? What do I do? Okay, do the opposite of what we did last time. The last time we hit log of this and then distributed the negative. And then we were done. First, so I'm doing the opposite. Now I distribute the negative. So distribute the negative, negative 5.2, or you could say multiply both sides by a negative, get rid of the negative on this side, equals log of X. Okay, now, I have to solve for this. I need to take the anti-log, or the inverse log. Back in my day, we call it the anti-log, the opposite of log. So when we're solving for pH, you're taking log. Now we want to solve for the hydrogen ion concentration, which is the opposite. So now we solve for the anti-log, or inverse log. Well, how do I do that? Log button. Second function, log button. Okay, let me show you. Okay, I need to take the second function log, the inverse log of that number. Okay, so on my calculator, okay, clear this out. There's my log button. Okay. And you can see up here, 10 to the x. Ooh, remember I was saying that exponents, logs are exponents? Yeah, 10 to the x. So we have the 10 to the x part here. And what we're trying to do is get out of that. Ooh, where did we go here? There's my finger. There. And go to this. So what I do is I hit, doing this through the camera, second function log. I didn't hit log, it's second function log. It's the opposite of log, the anti-log, the inverse log. All right, and it's doing that. See, it puts 10 to the x because logs are exponents. And it says, well, what exponent do you have that you want me to get rid of? And I put in negative 5.2. And you have to put the negative in or you'll get an error. You have to put the negative in. So negative 5.2. So negative 5.2. Okay. Hit enter. Boom! We got our answer. That's the concentration of the hydrogen. Can't read that. 6.31. 6.31 times 10 to the negative 6th. 6.31 times 10 to the negative 6. Well, let's just check the answers and see how we did. Dang, we're good. We're good there, lab partner. All right, now remember I said that logs are exponents. So when I get a times 10 to the something for an answer for my concentration, it should be in the range of, I'm going to say 4 to 6, right? Somewhere in that, just a little off of what this is for an exponent. And it is 10 to the negative 6. Okay, all right, so my concentration was, and I rounded it to 6.31. Times 10 to the negative 6. That's the concentration of the hydrogen. All right, we got that one done. B. A pH, a solution whose pH is 16. I just thought this is interesting because most of the time pHs don't go above 14, but they can. You can get super basic solutions. So what would the concentration be? I lost it. pH of 16. Okay, so the pH of 16 equals negative log and you want to know the H concentration. I know the answer. I don't have to hit it. Not because I looked, no, because I know. These are exponents. It doesn't have any number in front. It's not like 16 point something, is what I mean by that. It doesn't have 16.3 or 16.5. Like the last problem was 5.2. So we didn't come out in an exact 6 because of the 0.2. This is 16 right in the button. The answer is going to be 1 times 10 to the negative 16th. It is. You try it. Let's do it. Logs are exponents. Okay, so let's go ahead, distribute this. Negative 16 equals log x. Get the anti-log first. Okay. Second function log. I know I'm making myself sound old. I am old. But when I say anti-log. So second function log negative 16. Enter. Boom. I already knew that. 1 times 10 to the negative 16 is the concentration. So the hydrogen ion concentration equals 1 times 10 to the negative 16. That's 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is a strongly basic solution, hence pH 16. It's way up there in the alkaline range. So we should have very, very little H. Because remember, H is acidic stuff. It's not acidic. Nope. Very little of it. Hopefully that makes some sense to you. I want the chemistry to make some sense, not just get an answer. That's just a very little amount, very weak amount of hydrogen because it's such a strong basic solution. Okay, let's do the last one. A solution whose OH concentration is 3.7 times 10 to the negative 9th. I wasn't given the pH this time. So I don't have to use a pH equation to solve for H. I would just go ahead and use this. I mean, I could use that concentration, put it in here, get a pH. No, don't do that. This is the easier one. I was given the H, right? No, I wasn't given the H. You want to find the H. You want to find the H, I was given the OH. Yeah, I was given the OH. So I want to find this, call that X. I was given the OH. Now we could put the OH in here. We can get the POH. We can then take the POH, subtract it from 14 and get the pH. And then from the pH, we could do what we did in the last two problems and solve for H. Don't do that. This is the easier. Just do it this way. If you're given the concentration of one and you want to find the concentration of the other, use the KW relationship. All right, put that in. 3.7 times 10 to the negative 9th. 7 times 10 to the negative 9th. Okay, we're going to divide both sides by 3.7 times 10 to the negative 9th. You look at those exponents, you subtract them. We should come out with this concentration here somewhere around, I don't know, 4, 3, 4, something like that. So go ahead and divide. 1, second function exponent, negative 14. Divide 3.7, second function exponent, negative 9. 6. 14 minus 9 is 5. 5 to 6, yeah, that's right. It's 2.7 times 10 to the negative 6. And what do we get? 2.7 times 10 to the negative 6. Bang. So the hydrogen ion concentration is 2.7 times 10 to the negative 6. Look at these concentrations. This is the hydrogen, that's the hydroxide. What would the pH of this be? Predict. Acidic. Because that is a larger number than that is. More hydrogen than OH. Acidic solution. All right, okay, we completed number 4. Another relatively short video compared to what they could be, right? So we'll pick it up. No, problem number 5. And yeah, okay, problem number 5. You're going to love problem number 5. Oh, you just wait. You're going to love it. You are going to love it.